Hi, welcome back to the breadboard. Today we're doing a review on and having first looks at the Kaiweets Smart Digital Multimeter, as you can see here. Ignore these other pieces for the moment. We're just going to use these as part of testing this. This is sent to me from Kaiweets directly. They asked me if I'd be interested in having a review of it. It's new on their lineup, so I said yes, of course. There are no payments going on. There are no conditions about whether I say it's good or bad or whatever. I will just give you the truth about it. Now, my history with Kaiweets products so far has been pretty good. I found them to be very accurate. Again, possibly not using them in like real-world industrial environments, but certainly for home, domestic, office kind of spaces, they're more than capable. You just have to be aware of the limitations from a safety perspective. Anyway, I'm not judging this particular meter yet because I haven't had a look at it yet. So without further ado, let's get inside of it. Okay, first thing of note is it's in a rather nice transporting case, and we've got what looks like a fairly substantial manual. Quick glance at the manual. It's in multiple languages, Chinese and English. Well, I guess 2 languages. That goes through all of the different settings, jack indications, category ratings, safety information. Safety information is always up front. Specifications, actually the actual accuracy is on the back. So let's just have a quick look at that before we look at the meter. Just so we set our expectations. Alright, on DC volts, 0.5% plus or minus 3 counts. Input impedance approximately 10 megohms. AC voltages 0.8% plus or minus, well, sorry, 0.8% plus 3 count. Input impedance again about 10 megohms. That's fairly typical for multimeters this day and age. Operating temperature 18C to 28C. That's accuracy with an operating temperature of 18 to 28, and relative humidity between 0 and 80%. So it's 10,000 count, basically goes up to 9999 counts. Sampling 3 times a second. It's got a damaged fuse indication, jack indicators. Runs on 3 AAA batteries. Hopefully they'll be included. Environmental conditions. It's got Cat 4 at 600 volts, Cat 3 at 1000 volts. Max voltages between terminals and earth is 1000 volts or AC 750 volt. It's got a 600 milliamp fuse and a 10 amp fuse internally. Hopefully they can be easily accessed for replacing, because it's not if but when you pop one. And that's it. So let's have a look what else it will do here in specifications. AC DC current 0.8%, 1.2% at the 10 amp range. And capacitance, it will be 4% or 5% at the higher capacitance ranges. Diode and continuity resistance is 1% plus or minus 1%, 5 count plus at the highest range, which is 99.99 megohms, which we can test up to 1 meg on my resistance box here. 2%. I suspect it's going to be a lot more accurate than that. It will measure frequency and temperature, so maybe there's a temperature probe in here as well. Alright, and 3-year warranty. Alright, let's get inside and have a look at this puppy, shall we? So let's zoom in. The case is nice and solid. Reminds me of the kind of case you get with glasses, like for protecting them and things. It's looks quite nice. Okay, here's the meter, a bit glary, but so we have the LCD portion, some buttons at the bottom, bag full of probes. Let's pull these out. I guess you get 2 sets of batteries. That's nice. Let's pull the meter out. Keep the case aside for the moment. We'll have a look at the meter in just a moment. So we've got 2 sets of batteries. So let's pull one of these out. I'm not sure how long these may or may not have been sitting in the case for. Oh, that's how I didn't notice in the specifications how long it will run on the batteries. Okay, there's 3 batteries to put in. So we get, looks like we get a temperature probe and some cables. We're about 21 degrees where I'm sitting right now. These feel like PVC. It's tough to tell. It says 2000 volts, 80 degrees, 20 amp. I'm not sure if these would take 20 amps, but that's what it says on them. On the probe end, they've got covers for the cat rating. When you've got these covers on, there's only the tip exposed. You can change the cat rating. So that's cat 4 at 600 volts. If you take this off, you actually reduce it to cat 2 at 1000 volts. This is all about category ratings. I've talked about before, is all about where you can use the meter and things, not the voltage ranges. So these actually on here are rated at 10 amps. Again, even at 10 amps, these are, I guarantee you, these will get warm. They all do. It's not just these. It's even Fluke and RS and Agilent, everybody else. They all get warm if you try and pull them the max current. That's a max current, not a recommended current that's written on them. It looks like a standard thermocouple. So it's about a 3-foot cable on there. It's braided, cloth braided. So that's good. Okay, let's have a look at the meter, shall we? So obviously we haven't turned it on yet because it's got no batteries in. So we've got a range button, relative hold. So the relative is going to be a 0, so you can 0 the reading and then see what the difference is with another reading. Looks like it's got 4 LED indicators which match the holes on the bottom for connecting. It will probably flash to tell you which one you're supposed to be using. We have a selection and a min-max, and then an auto or function. I'm not sure if it is a touch screen. I know I mentioned that before. I guess we'll find out. On the top we've got a no contact voltage sensor and a power button. On the back we have looks like a flashlight. On the side we've got an APO button, and on the other side we've got a button to turn on the flashlight and off. Okay, I'm just going to zoom back out a little bit just that you can see everything we're doing. So the first thing I guess we need to do is get the batteries in. So this has got a little booty on it for protection. So let's try and get that off. May not be easy. It is rubbery. Not sure if it's actual rubber, but it looks pretty substantial. Give it a bit of drop protection. So let's get this open and see what's inside, shall we? Looks like they screw into plastic, but I mean these are meters that are built to a price to compete in a certain market. So things like heat set inserts for machine screws is sometimes one of the things that goes. Looks like we've got a combination of heat set and a brass insert at the top one. Oh, that's because you don't need to undo these ones. We will have a look inside anyway. Looks like the top cover clicks on with just the single screw, and that's the one you're going to be replacing most of the time. So batteries will go in here, but as Dave Jones says, don't turn it on, rip it apart. And we're going to have a quick look inside, so I'll take the other 2 screws out so we can have a look inside this before we power it up. Basically. Okay, here we go. So it's just very, very tight fit. So we just take it apart. So we have 2 ceramic fuses. On the back of the case we've got the buttons reaching through to the PCB on both sides. Battery connections are via clips, so there's no wires to unsolder or anything else, which is nice. Clear inset for the flashlight to shine through. That's nice. So what do we have on here? Let's just zoom back in again. Okay, I'm going to tip this up because there's a lot of reflection from the lab lights. So we have the main, this is probably the controller for the board, for doing all the measurements and everything else. This top one is probably the LCD driver. We've got lots of diodes here, probably protection diodes. We've got a relay, and that's on the top board. And the processor for the LCD is a TM1729. We've got a resistor divider chains down here. Now they use lots of resistors because they're trying to maintain a voltage rating for the multimeter, and so by using lots of smaller resistors you can increase the voltage across them all because it divides it up basically. We've got some heavier duty ones here which are probably for current measurement. I don't see one that would handle 10 amps specifically. Which one is the 10 amp terminal? It would be this right hand side one. So this fuse is the 10 amp fuse, the current sense. Okay, taking all the screws out. We're looking at the underside of the board here. We have a very large backlight panel and with the two wires coming up. There's nothing else on here except for connections for a zebra strip which goes to the LCD display. That's the near voltage, no contact voltage sensor. On this side of the board there's just your 5 buttons for your various function switches, some LEDs for lighting up which range you're going to select, and looks like here is the 10 amp. Let's get that in shot. I don't know if you can see that. There is a thin strip of probably nichrome or something running from here along the back edge of this to here, and that's going to be your 10 amp range sense. So there's a lot more screws in here for holding this down, and the reason for that is because we do have the 2 zebra strips that are connecting the PCB to the display, which is a separate unit in this meter's case. So you need to make sure you have a nice even pressure for that zebra strip to make a good contact. Anyway, let me just continue putting it together. I will completely assemble it, put the batteries in, and then I'll be back. Okay, so we're ready for first power up. I guess the one downside that I've seen with this so far is that if you do pop a fuse, you have to take the back completely off in order to change them. It would be nice if they were exposed so that you could pull them without having to take the entire back off. Have to hold it for a couple of seconds, I guess. Alright, so we have full auto mode right now. It's reading 23.5 degrees, which it's been in my hand and things. That's probably about close enough. What we have on here is we've got voltage, AC or DC, ohms, beeper, diode, capacitance, millivolts, AC or DC, hertz, and duty cycle by the look of it. It's got a percent symbol, degrees C, degrees F, NCV live, so that's for sensing mains, milliamps and amps range. So let's do a couple of basic things here right now. Excuse the phone beeping away in the background. Let's put the external temperature probes in and see if that correlates. Which one is for temperature? I guess always this right hand side one. So it's on auto, so is that gonna... So it's doing a continuity test on there, so that's not quite what we want. Let's manually... Looks like you have to cycle through all of the ranges to get to the one you want. There we go. So as I said, my lab is about 21. The one you saw before was from an internal temperature sensor, and it's given us both degrees C and Fahrenheit. If I stick my finger on here, so that works okay. Let's get back to something else. Let's try with using the probes here. We'll go and do some, so if we go back to auto, get rid of these probes. This is flashing the lights for the range, it thinks. Actually, that's worth having a quick look at. If I just cycle through these, so it's telling you, you can see the lights are flashing to tell you which connections to use. That's nice to help out. Ohms, beeper mode, same connections, diode mode, capacitance, millivolts. The only time this should change is when we get to these two at the end. So there's your milliamps, and then you have your 10 amp range. And we're back to auto. So let's put the probes in, and we'll do a quick check on how accurate this is. Okay, let's measure some resistance, shall we? Yes, as you noticed by my attire, it's a different day. Had a haircut, changed my t-shirt, etc. Anyway, back to the video. Using my Vishay resistance standard that Vishay kindly made for me a few years ago. I'll put a link in the description to the video I made all about this. And I also have got the meter sitting here in auto mode, so we'll just check that first. We're going to check the accuracy of resistance measurements to start with. So I've connected the probe, negative, to the common connections on my resistance standard. Let me just quickly show you what's wiring like inside of this. It's just a crude diagram. Basically what is inside the resistance standard, we've got the common connections at the top. There's just the two posts for that, and basically they're connected together. This is a setup so that you can do 4-wire resistance measurements as well as just 2-wire. The top of all of the resistors in this standard are all common together. It's perfectly fine as long as you're not trying to use two different resistors at the same time. And we have 7 resistors: 1 ohm, 10, 100, 1K, 10K, 100K, and a 1 mega. Alright, so we're looking at the resistance standard. I've got the meter plugged in. So the first thing to check is on auto, which range is it going to check when I give it a 1 ohm resistor. Looks like it's locking into continuity. At what point does it think it's a resistor versus continuity? There you go. So as soon as you give it something 100 ohms or more, it gets into resistance mode. So I'm going to set it into permanently resistance mode, just so that we can measure the lower ends. Now when you first measure, you might get some errors. Like here it's measuring 0.6 ohms. It's actually a 1 ohm resistor. So let's just short these together and we'll hit the relative measurement. Hold and press maybe. There we go. The relative measurement will get rid of any offsets that might have been there. So now let's measure the 1 ohm. So looks like it was still quite accurate. It's a little bit low. Now the resolution of this and accuracy of this Kaiweets meter is such that it's of the percentages are of range. So 1 ohm, the lowest range this basically has is a 999 ohms. So it's well within specification. It's just not good at measuring these low values, but it is a, it's not a high-end multimeter that we're looking at here. So let's go 0.5 there. Let's go to, let's just check the 0 again. Yep. Go to 10 ohms and see how good that is. So 9.8, that's pretty good. Alright, going up to 100 ohms. That's pretty much exactly spot on. 1K, flip to the 1K range, exactly 1K, so that's good. 10K, pretty much spot on as well. My 100K, my 100K is almost exactly 100K. And 1 mega ohm, 0.998, and mine is 1.0, 1 point, lots of zeros. So that's still anyway well within specification for this multimeter. Okay, let's measure some voltages, shall we? What I have here is a precision digital voltage source that was designed and built and sent to me by my friend Ian Scott Johnson over in the UK. His website, www.ianjohnston.com, is where you can go to get one for yourself if you want to. This is one of the version 1s that I have. He's got a much newer version out now with more features and things. This is a very, very precise reference standard. You can dial in any voltages up to 10 volts. And what I'm going to do is check the meter for accuracy. I know this is spot on, so we'll check the meter for accuracy, and we will this is only going to go up to 10 volts for the voltage checking, which for most bench use is more than enough. We'll check some mains type measurement shortly, but that's getting into an area that I don't normally try to delve in with my tutorials or reviews, because I don't want to encourage younger people to be sticking things into mains receptacles and stuff like that. So anyway, let's get on with the measuring. So right now I have it set to 50 millivolts here, so 0.05000 volts DC, and what we're reading here is 48 millivolts on the meter. Now we're in basically the 0 to 9 volt range. I don't know if there's any less than that. That's the 100 volts, so yeah, that's the best range it's got. It's reading 48 millivolts. Let me just grab another meter, one of my precision ones, and do a quick comparison. One sec. Okay, so I've plugged in my Agilent U1272A, which is a much more accurate multimeter, and as you can see here, it's reading 49.9 millivolts for the 50 millivolt range, which is well within its accuracy, and we're reading 48 millivolts down here, which is still within the meter's accuracy, well within. It's just a little bit low. So let's dial in some additional voltages. So let's just go to 1 volt. And now you can see this is jumped up and is absolutely spot on, 1.000, which is excellent. And we've got 0.9999 over here. So let's go to 2 volts. So we're pretty much exactly 2 volts here. We're slightly high there, but again, it's within basically 0.1%, just fraction over 0.1%, well within its specifications. Let's go to 3 volts. Again, well within specs, exactly on spec. I would expect this one to be way more accurate anyway. This is, you know, a $500–600 meter, so there will be obviously a marked difference in accuracy. Anyway, well within specifications down here, 3.004, so it's still within, you know, barely outside of 0.1%, whereas its range is way worse than that from an accuracy specification perspective. So it's exceeding its specifications quite considerably. Let's go to 5 volts. So again, it's staying within specifications. It's got that slight basically a 0.1% offset there. Let's go to 7.5 volts. So again, this one is pretty much exactly spot on, just marginally out, but within its specification. This hasn't been on a huge length of time, so it could be just still settling down on its voltage references. So now let's go up to 10, and that is reading, oh, because we're on manual ranging, that's now reading 9.99 volts, which is pretty much spot on. Let's just go back down again, just check 5. Yeah, so it's still doing the same thing, 7.5. Alright, so I'm actually quite impressed with that. That's measuring very, very accurately. Okay, I've got a bucket full of random capacitors here. So we're just going to put them on my LCR meter. This is from RS Pro, which is radio spares, as it used to be way back known, or RS components, as it is now. So we're just going to grab some random caps out of it. So first up, we've got a 33.0 microfarad cap. Let's see what the meter reads, because we need to set it to capacitance. That's not within its auto ranging. So 33.85, the other meter read 33. Probably some variances with frequency that it's using and stuff. I think the LCR meter is currently set to 120 Hertz. The Kaiweets Km601 could be using completely different frequency, so it's still within specifications anyway. It's reading 33.8 microfarads, so that's good. It's a first success. Let's try something a little different range. Don't know what that is, does not look. So 978 nanofarads. This is a little 180 volts, 1 microfarad, plus or minus 20% cap. Made in the UK. Probably quite old, this one then. So yeah, what did I say that was? Yeah, 979 nanofarads. And the Kaiweets will read 971, so that's fairly good, and it's nanofarads as well. So 2 for 2. It's pick an old disc capacitor. Stick it in the LCR meter from RS, and we get 74 roughly nanofarads. It says 104, so it's reading a little low, but the tolerances aren't great, and these are also old, so they could have drifted. So 76, and we were reading 76 as well, so they're both reading and agreeing with each other, so that's cool. Let's pick one more just for the sake of it. This is a tiny one. I can't even see what looks like about 1 nanofarad, this one. I use the clips because I think the wires are not strong enough to go through the barbs on the front here, so let's stick that in there. We've got 1 nanofarad, or to be more precise, 1013.2 picofarads. So that's a 1 nanofarad capacitor. See what Kaiweets gives it. That gives it a 1 nanofarad as well. Perfect. Alright, so we've resistance, capacitance. What else do we have on the Kaiweets? We've got frequency measurement, we've got degree C, we've already looked at. There is a millivolt range. Let's just get this back out of the way. Bring in the Ian's digital voltage source again. So we're reading millivolts. This is set to 50 millivolts. And see how we get. See, that's much more accurate. On the voltage range, obviously it was a little further out. Now we're on a millivolt range. We've got much more accurate readings. That's plus, it's well within specifications. And on minus, well within there too. So, perfect. Let's go up to 0.99. That's good. So go 0.9999. Doesn't quite like that high, close to the 1 volt range, so 0.995. 0.995. Perfect range. So 4 for 4. Next one up is hertz, so frequency range. I'm just trying to think what I've got that will generate frequencies for me. Let me get. Okay, next stage in testing. We're looking at frequency measurement and AC measurement. As you can see here, I've got out my Agilent 33600A series arbitrary waveform generator. I've had this for quite a few years now. The one nice thing is that I don't really have any variable AC sources except for this, so I can use this at least up to about 7 volts RMS to generate some various frequencies and voltages to measure on here. So this claims, well, right now it's measuring on just AC volts, so there is a limit on its frequency response, although I couldn't find that in the book as to what that is, but we can quickly test it. So right now it's a 50 Hertz signal, 7 volts RMS signal, and you can see we're reading 7 volts right up there and 50 Hertz. So let's change the frequency to well, the other mains frequency, which is 60. So we'll go 60 Hertz. So that actually made it slightly more accurate. This is very accurate as far as its output's concerned. It's on high impedance mode. So we're reading 7. I mean, it was pretty accurate before. If I go back to 50 Hertz again. So 50, 6.996, dropped a tiny bit. So let's go up to 100. That's 90 Hertz. There's 100 Hertz. So we're still reading accurate. See how far we can go. 200, 300. Still reasonably good for AC measurement. 300 Hertz there. 400. It's dropping. It is dropping off a little bit, but still reasonably accurate. 600 Hertz. Let's go up to 1 kilohertz, shall we? 1 kilohertz. So it's starting to drop down a bit there. It's about just over 1% low, which is still within its specifications, although there is no specifications for the frequency response. So it looks like you can measure AC volts quite accurately up to, well, at least on the lower voltage range. I presume the higher voltage ranges are going to work just as well. And we've already done DC voltage checks for some of those. Let's change the amplitude to something lower. So let's just say 1 volt RMS. This is still at 1 kilohertz. And that's reading quite accurate. So let's go down to 100 millivolts RMS. Let's flip range to the millivolts. Oh, and we have to select AC. There we go. So that's reading pretty accurate for 1 kilohertz. It measures the frequency as well, and the volts is reading accurate. So that's good. Let's go down to 10 millivolts. So that's doing pretty good. 1 millivolt. And it's still doing very good. So I think that's probably good enough for checking the millivolts range. It's stopped reading the frequency, so let's see where that would be. Okay, so it reads for 100 millivolts. Yeah, 10 millivolts, it lost its ability to track the frequency. So that's at 20 millivolts, it's still tracking the frequency. So that's pretty good. Let's go up to a 1 volt. No, let's pretend we're measuring some kind of frequency from a microcontroller or something. So let's go up to a 3.3 volt RMS signal. We'll have to go back to, here's a negative of this. You have to go all the way through your ranges to get back to the one you want. So we're at 1 kilohertz there, it's reading that. So let's change the frequency and see where it drops off measuring frequency. It'll lose the voltage. Or may do soon. So that's still not bad. It's reading the voltage wrong now, but it's reading 2 kilohertz. So on voltage measurement AC, it can go up to what it looks like is about 6 kilohertz, but you're losing accuracy anything above 1 kilohertz. That's still not bad for a meter. So now what we will do though is we'll go to the frequency range and see if that's any better, because it claims up to where is it, frequency up to 10 megahertz basically, with an accuracy of 1%, plus or minus 3 counts. Sorry, plus 3 counts, there's no minus. Yeah, so let's start with 1 hertz. So let's put in 1 hertz, and there we go, 1.000 hertz at a 50% duty cycle. Let's go to 1 kilohertz, and that's pretty much spot on at 50% duty cycle. Let's go up to 100 kilohertz, and that's still pretty accurate. That's good. 1 megahertz. That's doing good. And we'll go up to 10. This might be over range. Nope, that handled it. The maximum it says is 9.999 megahertz for the range, but it looks like it will go over that. So let's try and see how far it will go. 13, 18, 20 megahertz. I'm going to change the waveform to a square wave. Seems like it's not too reliable at 20, but it definitely does the 10. I've just dropped it to 10. Let's go back to the square wave. Okay, that's still reading nicely 10 megahertz. Let's change the duty cycle. So set it to 25%. It's not picking up on the duty cycle at 10 megahertz. Let's go down to 1 megahertz and see if it has a better time of it. Nope. 10% duty cycle. That's like, let's turn the output off. Okay, meter's a tad slow on that, but let's put it back on again. It's got a 10% duty cycle at 1 megahertz, and it's still reading 50% here, which is not correct. Let's take it down to 100 kilohertz, shall we? Okay, now it's reading it, so it looks like at the higher frequencies it doesn't like measuring duty cycle. It just sticks to 50%. Probably part of its internal algorithm. Okay, duty cycle 1%. So down at 100 kilohertz, it does seem to be doing quite okay with the duty cycle-ish. That's a very narrow duty cycle, of course. Let's go up to 10. That's pretty good. 20. That's good. Let's go up to 50. We know 50 works. Let's go to 60. That's good. 70, 80, 90% duty cycle, and let's go up to 99. And it's still seeing ish that. So not too bad, not the best, but not too bad. Let's go back to 50%. And it's getting that quite okay. So that's with a 3.3 volt peak-to-peak signal. Now it's frequency. So we've already looked at the centigrade Fahrenheit. Okay, we'll just get this out of the way and we'll go on to the next one after that. Okay, so the next thing, excuse the mess, we're getting messier here as we go through this. On the range that we haven't covered yet is the no contact voltage sensing live. So we should be able to detect this mains cable, which, there we go, didn't detect it over here because on the end of here, that's the no contact voltage sensor. That's just the on-off switch. So we put it near here. Obviously rotating the cable puts the mains lead nearer, the live nearer to the meter. There, no contact, no. So it gives us an idea of it's a high voltage, but it's still green. And it's a really high voltage and it goes red. So okay, now does it work with obviously sticking a single probe in? You don't have to put both in. So that's live. That shows high as well, and that's the ground lead. So it's, either way, it's still, this is plugged into mains. It's still sensing the high voltage on any one of those. Now if we go to, I guess we could do an AC voltage check before we do the milliamp. I'm just going to freeze it to AC, so we should be able to, don't do this at home. So it's not picking up the AC there. Let's change it to AC. Now it's figured it out. So 123.6. If I do that between there and ground, right? So 100. So that one on the right is the live one. If I put it on the other side, we shouldn't get that. You might get a volt or two. 0.8 volts, which is, you know, it's relevant to ground, but at the switch box, the fuse panel. So that's good. Now I'll unplug that before I hurt somebody, namely me. Okay, that was a little bit on the high end AC voltage. You can see it's showing 60 Hertz as well. And now let's go and check the milliamp if I've got something to test it with. Okay, this one is a little bit noisy, sorry about that. Been a while since I've had this out. This is my little DC load. I have a big one too, but it won't fit on this bench. And of course it reads the voltage at the top. So I've connected it to a power bank. We're feeding it through the meter. Right now it's set to the amps range. And the power bank probably is going to limit it out about 2 amps. So you can see here I've got it set to 498 millivolts, and we're reading 498 down here on the current range. So let's crank it up to an amp to make sure I'm on the right input. If I was on the milliamp input, I would have blown the fuse by now. There's 1 amp, and we're reading nicely 1 amp. Should be able to, and my DC load is dropping a little bit. Sorry, my power bank output voltage. Should be able to go up to 2 without it dropping off. Almost there. It's dropping off a little bit. There we go. 2.008, and we've got 2.012, so it's still within specifications. This is DC amps, not AC, of course. Probably go up to about 2.5, but that would be about the limit of what I can do with this. So the volts has already dropped to 4 volts. So the power bank will give up the ghost shortly if I keep going higher. So there you go, 2.501, 2.507, still well within specification, so that's excellent. Let's drop the current way back down again, and we'll switch to the milliamp range, and we'll just go a little more carefully. Now crank this right down. Okay, so we're setting at about 2 milliamps. So let's change the range. No, change the input, sorry. This doesn't have any other ranges but 10 amps. We've got to go through everything again. But of course, it's not going to let me with the probe connected. That's actually a nice feature, that it won't let you change it with the probe connected. If I put that in milliamps and then put this back into the amp range, it's actually changed to the amp range up here. So it's got sensing on the inputs, which is nice. Put it into the milliamp range, it's switched back to the milliamp. And we've got 2.9 sitting up here. This is the pot at 0. And we've got 2.8, 2.9 down here as well. So it's correlating at that range. Let's go up carefully. I don't want to go over the fuse rating. 100 milliamps, close enough. 1.03, 1.03 on the milliamps. Let's go up to 250-ish. So 252, we're reading 253, still close enough. We'll go close to its limit. We'll go to 500 milliamps. I think this is rated to, well, the fuse is rated at 600, so I'm not going to go above 5. That will be heating up the fuse. Okay, 502, got 503. That's flickering around a little bit. So that's not too bad. I haven't, as I said, I haven't used this for probably a couple of years, so it may not quite be accurate. I might have to readjust it, but close enough. So you can see we got 5.03, 5.02. Sorry, 502 versus 503. So yeah, pretty good. I think that's everything now. All right, let me just turn this off so you can hear me better. Here we go. That pretty much covers every single range of the multimeter, and also yeah, still warning me that I'm on a current range. Back to full auto smart range. So what do I think of this? Well, it's a nice handy size. I wouldn't be using it for industrial applications, but really it's probably not meant for that anyway. For home use, like automotive and things like that, it's going to work fine. For automotive, be careful that you know, with a car battery, you can easily have spikes over 10 amps. It will pretty much immediately blow the fuse. But around the home, for electronics and stuff like that, and for audio kind of frequencies for measuring on the AC, I think it will probably be perfectly fine. And it looks like, you know, up to 100 kilohertz, it was doing pretty good for AC measurements. So that would work for audio. DC resistance, capacitance, etc. all seem to correlate well within specifications. You've got the benefit of temperature measurement and also a zero contact voltage sensing as well. Although, to be honest, there are better tools for sensing whether a main circuit is turned off than a meter. I mean, a lot of the newer ones have it, but the range here is limited. I have to be almost on top of it to sense it. So if you're trying to see if a socket is still live, it's not going to do that for you unless you plug the lead in which case you're bringing, 120 or 240, 50 volts right up to the meter. And I would be reluctant to use them on that. But I mean, I say that for all the meters that are in the $50, $60 range. If you want to be working with, powered circuits and things like that, then, it's worth investing the money in a well-known brand, higher end multimeter. If you're just doing this, as I said, for a hobby and part-time, then this would probably do, but you just got to be careful, very careful. This is designed to be able to withstand it. You could put this across mains on the current mode, and whilst you'll pop the fuse, you probably won't damage the meter, but what you won't do is have the meter blow up in your face or anything like that. It's built to withstand it, and it's got all the safety things built in. When we looked inside here, you could see there was very little as far as MOVs and protection. There was a little bit of a gap cut in the PCB, but nowhere near as much of protection systems as this has built into it. It could be fluke, it could be, this one's an Agilent, Keysight in this case. But the choice would be yours, but I would suggest for industrial use and if you're doing this for a living, to get a higher end meter. But yeah, this will happily sit in your pocket. It'll happily work with, go in your toolbox and things like that. It's small, it's cell phone sized. Its accuracy seems to be well within the specifications, well better than I expected actually. And I don't know how much it costs on it. I guess we'll have a quick look to see how much this costs. Kaiweets website. Got a Black Friday sale coming up to 50% off of a lot of equipment, so worth having a look. And here we go. Black Friday's in full swing. So yeah, from 55 to 45. So this is a $45.99. So that's probably American. So yeah, I think that's not a bad little multimeter at all. It's easily readable, good functionality, pretty accurate on most of the ranges. The extra benefit of having temperature measurement, you get a temperature probe with it. The leads are not too bad, but you may need to buy some additional ones with little croc clips on the end and things like that. I think the biggest downside about the meter is the fact that I have to select the range up and down. As you can see on here, when I press this auto function button, you have to cycle all the way to the end and then go back to the beginning again. Now fortunately the milliamp and amp inputs are separate sockets, so it's probably safe to go through those if you've got a high voltage on one of these. It shouldn't damage it. That's part of the safety mechanisms built in and protection mechanisms. But I would recommend, if you're going to be going into an unknown, to set it to what you expect. Like, always probably safer to fix it to voltage input and then measure, and then unplug and pick the next one you want according to what kind of test you're doing, rather than just cycle through them, because you do always, even with other multimeters, you can run the risk of damaging the multimeter. The safety in them, the Cat 5 rating and everything else, or the Cat ratings, is all about protecting you and declaring the zones recommended for the meter to be used in. So yeah, for home use, everything else, perfect. Alright, yeah, this would make a good Black Friday gift. It would make a good Christmas gift or birthday or something like that for somebody that's getting into electronics, needs a fairly good functional multimeter that does a wide range of things. and this seems to be doing the trick. So if you liked the video, give it a thumbs up. If you didn't, then don't, and I will see you soon. Bye for now.